live. Don't ask a stupid question. Let me make sure we're live. Yep, there we go. Woo-hoo-hoo, I think. It says it is. There it is. It's a little laggy. Huh? Nah, I'm good. Okay. So I got through with all my dog. Oh, sorry. And then, I gave you don't have to do it anytime soon, a Google form to sign in. This is your syllabus quiz. It's not a quiz. It's just a syllabus for you guys to sign to make sure you read it and you understand it. And there's 6 or 7 different questions on there. Hit me.
It says that you need access to the syllabus form.
Well, gosh, cuss. Okay. Learning. So at some point I'll do that. I don't know why that doesn't happen. They changed all this stuff to make it better, and then I got to relearn crap. Thank you. So I'll get that fixed too. So, all right. Anything else about house cleaning? This, like I said, guys, these are your notes for all year. Try not to lose it because it's your notes for all year, okay? You'll see it starts with chapter 4. That's what we start with. So if there's ever any confusion about what's going on, at the very beginning, okay, this is a formula sheet. You are allowed this formula sheet anytime that you need it, okay? On tests, I will give you this formula sheet. You will not need it for test 1. So that's the formula sheet. That's page 1 of the formula sheet, and then here's page 2 of the formula sheet, okay? And I'll refer to it several times. And so I just put one in your notebook. It's at the very front for you guys to refer back to at times. I really don't believe you will use it hardly ever. But it's there and it's available, and some of you guys might. Right after that, you'll start seeing some tables. We won't use these until later, but anyway, there's one table, here's a table, here's a table, here's a table, and here's a table. We'll actually use this table today, the one that's it's on T5. We'll use T5 a little bit today. And then that's probably the only time we will ever use it. Bless you. And then I got, calculator functions. This is new that I added this year. Students said that I don't know how to mark my calculator and I forget. So this, I don't know if it's going to help you or not, but I put that in there, okay? That's 3 pages. This will not be until 2nd semester. And then finally, we get to chapter 4, okay? Chapter 4. I do want you to be aware of it. It does say unit 3, and it says chapter 4. So AP goes by certain units. AP has 9 units. AP has 9 units. We have 12. We have 12 chapters. So why there's not 9 chapters, I don't know. But there's 12 chapters. So chapter 4 is unit 3. And then we're going to go to unit 1, which is chapters 1, 2. And then unit 2 is chapters 3. And then at some point or another, we'll lose another chapter, but who cares? Just kind of be aware of that. I want you to be aware of that is if you go to AP Classroom. Because if you go to AP Classroom and you look up unit 4, you're not going to find anything that I'm talking about. Because that's unit 3. Y'all okay with what I'm saying? So that's the only reason why that's there. And that's why why is Thursday, yeah. What am I doing? There you go. And that's why the slide will say chapter 4, unit 3. Okay? Again, just kind of be aware of that. Every slide is the same color. I do black and gold. I tell you what the section is, and I'll tell you what the name of it is. On the calendar, I'll just put 4-1. Okay? Yay. And then the notes start, right? Then the notes start. And you'll see 4-1, 4-1, and then you'll see 4-2. I will say that I did go through the notes this year and cut a bunch of stuff out. I talk too much and I give you too much information. I have come to the conclusion. So I've actually keep cutting stuff and keep cutting stuff and keep cutting stuff. Ironically, when I keep cutting stuff and keep cutting stuff, the percentages have still gone up. So I think I've decided I'm giving too much information. So here that is, yada, yada, yada. At some point, oh, never mind. That's a different course. Yeah, I do. I understand it. And then Unit 1, Chapter 1. But that's, okay, good? Yippee-yo. All right. So put your name on it, draw on it, whatever you want to do. Oh, in the very back, I added this at the very back. So here's a TI-84 reference sheet. This is also a calculator reference sheet that might help you just in case you forget how to do something. However, if you're at home, look up YouTube because they'll show you how to do it. And then at the very back, guys, these are like quick notes. So really it's for review, but like this is all of chapter 1, or yeah, all of chapter 1, all of chapter 2. So it's like, it's abbreviated notes, mostly for you guys for when we start reviewing for the exam. However, when you start reviewing for your chapter exam, you might look at chapter 4, and basically that's all of chapter 4 right here. Everything you could possibly want to know. Kind of somewhat summarized. Bless. So I added those this year also. I printed them off and gave them to students at the end of last year, and several of them said, I wish I had this at the end of each chapter. So I said, well, I just add them. So all of this is kind of a work in progress. Okay, with all that stuff. Somewhat try to remember those type of things. Okay, beautiful. Dog and pony show's done. All right, now I finally get to do what I get paid to do. I don't get paid a whole lot, but I get to do it. Basically, I'm doing this for free. You're welcome. Okay, click, click. You better start clicking. You are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Why are you not clicking? You clicked all day yesterday. I'm not doing this slidey thing. You can hardly go a single day without something working like it's supposed to. This thing is getting ready to get kicked to the... I wonder if I plug my receiver in. Sorry, ADD kicked in. Where is my receiver? It's right here. Plug and unplug. Uh-oh. Ha 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 ha. Sorry. What the heck? You can't outfox a foxer. Okay. Now I can hit this button. Oh, cuss! Sorry. Forgot one other thing. Okay, now. I don't know where I put my little pins. Okay. You can hardly go a single day without hearing something about statistics. The National Highway Traffic Safety Administration reports that seatbelt use in passenger vehicles has increased from 88.5 in 2015 to 90.1 in 2016. That's when a big seatbelt campaign came out. Buckle up, save lives. So it went up from 88 to 91 or 90. According to a survey, U.S. teens ages 13 to 18 use entertainment media, whether it be television, internet, social media, listening to music, nearly 9 hours a day on the average. Right? You hear all this kind of stuff. Studies suggest that lack of sleep increases the risk of catching a cold. For their final project, 2 AP Stat students show that listening to music while studying decreased their performance on a memory task. One of these things that's kind of interesting about the book, maybe not always my notes, but at least the book, every single question, it's like real. Like it's actually been done. It's not something that's made up. It's not anything that you read. If you say, I wonder, you search for it and you can find it. It's actually been done. So that's something that's at least interesting. And I think that's one reason why they come up with so many different versions of this book, is because they update all these studies. Say again? Yep. Yeah. Just reading what it says. Oh, it is, isn't it? Yes. It didn't give you a whole lot of information, right? And that's kind of what they're alluding to, right? You can hear something, but then there's some more context to it, right? We're going to do something like that today. Can we trust everything we see or hear or read? Absolutely not. Except it's on the internet, you got to believe it, right? Let's look closer at one of those. So the one that says the National Transportation Safety, right? Went up from 88.5 to 90.1. Let's look at that a little bit closer so that we can get some context. Each year, the NHTSA conducted an observational study of seat belt use in vehicles. So what they did is they sent a trained observer. I don't know how you can train somebody like you wear a seatbelt, you do not. I mean, that's really training you. If they got paid for that, sign me up, right? They record the behavior of people, behavior of people in vehicles at randomly selected locations across the entire country. Okay, so when we start looking at this, now we know, okay, well, we didn't just go to one intersection here in Bentonville, Arkansas. We went in the entire country, and we went to some intersections just randomly chosen across the entire country. We still don't know where, but we do know it was the entire country. So it was randomly here, whatever, okay? The idea of an observational study is simple. You can learn a lot by watching or asking a few questions, okay? Observational study, we do it all the time. We look at people and we get information about it, okay? Common Sense Media conducted this survey using a random sample of 1399. It couldn't get one more person, I guess. U.S. from 13 to 18-year-old. Now, how they knew that they were 13 to 18, I don't know, I guess, unless they were drivers. But I don't know how they didn't know that they were under 18. Both of these studies used information from a sample to draw conclusions about some larger population. And we talked a little bit about that on Tuesday, where I was asking about the number of siblings, or I was asking about your favorite subject, right? So those are two things we need to talk about in statistics all the time. And one of them is our population. And I know the very first thing we talk about when we hear population, most of us think people, right? When we talk about population, we think of people. Sorry, hon, forgot. Right? But population doesn't have to be people. It could be whatever the heck we're talking about. That is the entire group of individuals. Now, guys, let's also keep this in mind. I don't think you will ever see me ask you for a definition on the test. Okay? I don't think you'll see me ask you for an actual definition. The entire group of individuals is what? You're not going to see that. Okay? You just need to know, you need to understand that's a population. It's not like it's a secret. I mean, that's pretty common sense. That's pretty common sense, the population. So if I'm talking about pine trees, then it's the entire group of pine trees. But now I might only be talking about pine trees here in Bentonville. So now that's the population, is every single pine tree here in Bentonville. If I'm talking about pine trees in Arkansas, then I'm talking about every single pine tree in Arkansas. I could be talking about the Southeast. I could be talking about the United States. I could be talking about the world. Again, it's just the population, okay? You guys could be the population of 0B, except I'm missing one kid. So I need one more to get the population of 0B students in room 325. Okay? All right, so that's the population. And then we need to know what the sample is, and a sample is simply a subset of that population. right? So if you guys are my population, this table could be a subset. It's part of that population. If I'm talking about pine trees in Bentonville, Arkansas, and I go to Pea Ridge, I'm not talking about those pine trees. So those pine trees don't do me any good at all because that's not part of my sample. So we got to distinguish the difference between those two, and it's not going to be a secret. Like, oh, are they talking about the sample? It's not going to be a secret. I mean, most of the time we're talking about the sample, a sample of, what was that? A sample of 13 to 18-year-olds. Well, now we know we're talking about 13 to 18-year-olds. We don't know where, but we know we're only talking about 13 to 18-year-olds, and it was a sample of them. So the population was all 13 and 18-year-olds. But then they tell me where. Well, it was across the United States. So now it's all 13 and 18-year-olds across the United States. Pretty easy, yeah? Okay with all that? All right, so census. Anybody know what a census is? Anybody know? Count up what? All of one. They do a census. I think it's every 10 years. In not in America. I think it's in the world, but I know it's in America. It's not a consensus. No, a census. Yep. So a census is data from every single individual in the population. In the population, a census is data from every single individual. Again, don't think of individuals as people, right? If I'm talking pine trees, and I'm talking about every single pine tree in Bentonville, Arkansas. If I'm talking about BHS students, I'm talking about every single BHS student. If I'm talking about 0-hour AP Stat students, I'm talking about every one of you guys, which I can't do a census because I got one absent. Okay, can't do a census right now because I got one absent. I'll have to wait for him to get back before I can do a census. Good enough for that? Census, all individuals. So, in statistics, we typically don't deal with census because census kind of knocks out why we do statistics. If you're going to do a census, there's no reason to do statistics, right? A census of you guys, let's just count that kid gone. So you 29, if I got your GPA and if I got all of your GPAs, I could actually calculate what your average GPA was for this class. I could do that. It's not that difficult because my population is pretty darn small. But as soon as my population starts getting bigger, it's harder to do a census. Sometimes it's impossible to do a census. The average size of fish at Beaver Lake. Heck, I can't even find one in that stupid freaking lake, much less all of them. Fair enough with that? So if you guys were my census and I did each one of your GPAs and I calculated the GPA for the entire class, then again, that would be the average for this class. There's no reason to do statistics because that is what it is. That's what it is. I mean, it's not above or that below. That's what it is. So there's no reason to do statistics. If I'm doing statistics, what I would do is take a sample somehow, and again, that's what we're going to talk about this entire chapter. I'm going to take a sample somehow. So let's just say, here's my sample. So I'm figuring out hers, his, and hers, that GPA right there, and figure out that average. Is it close to the class? Probably, but it's probably not exactly the same. It's probably a little above it or a little below it. It may be a lot higher or a lot lower. If it's a lot higher, then we call that unlikely. And if it's unlikely to happen, something's wrong. Something's wrong. And the way this is really into the future, but what we say something's wrong is this thought of what the class average was is not true. It's really not that. It's really not that. It's higher than what we thought it was. Okay? So, census. Here we go. This is our first little activity we're going to do this year. Don't look at the other side. You can read this all you want to, but don't look at the other side. You can look at my little froggy, and you can look at the instructions. I don't care, but don't look at the other side. That's breaking the rules. Oh, there you go. Now that better not flipped over. flipped over. You're wrong. Don't be cheating. Chloe, talking about you. There, you got 2. There, you got 1. There you go. Here you go. There you go. Did I get y'all? I get y'all? Yeah. Okay. We're going to see how reliable, everybody got a paper, yes? How reliable a census is. Okay, we're going to see how reliable a census is. So on the other side of this page is a story. Okay, it's a story. And in that story, we have some gremlins. So picture that other story as maybe a product of something. And so this product is coming off the assembly line, i.e. words, okay? And every once in a while we have a bad product. So the bad product happens to be the letter G. I don't have one up here. What did I do with that pencil I finally grabbed? So just so we're clear, I know most of us are at least in we're in high school. That is a G. Don't be confused. That is also a G. Your job, here in a second, when I tell you to flip that paper over, is to count these bad products, these gremlins. You're going to count these G's. Everybody knows what a G looks like. You don't have to count anything else but the G's. Easy task. The only stipulation is I'm going to give you a couple minutes to do it, not rest of the class period. Ready, set, go. Hey Siri, set timer for 1 minute.
1 minute, counting down.
4, 5, 8, 7, 6, 15, 2, 4, 1, 3, 7, 8, 9, 10, 15, 2, 18, 19. We're at 20 yet. 4, 5. Stop it! I think I gave you the wrong amount of time. I think I need to give you 2 minutes. You guys got it. Take coming. Are we at timer? 1 minute start. Yeah, I'm supposed to give you 2 minutes. When you get done, flip your paper over and write your number in that blank. Whoop, it didn't start. Maybe it did. Did it? No, it didn't. All right, here we go. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, flip the paper over. Write your number on your blank. We're going to start right here, and you're going to tell me your number. What you got?
56.
56? Okay, so currently I have 29 sets of data. If you just give me those numbers, it doesn't do me any good just to give me these numbers. Even if I write all these numbers down up here, it's hard to see what's happening. So I'm going to take a picture of these numbers. That's chapters 1 and 2 and 3. So he gave me 56. I'm going to put a little dot right here at 56, right? And because every single person knows what a freaking G looks like, I should have a bunch of 56s. What's your number?
52.
You got 52. What you got? 74. What you got? 77. 4. 5, 8. Okay. We already got an issue, guys. Nothing. Okay, first of all, I was pretty sure I went over what a G looked like. I'm fairly certain that each one of you know how to count. There may have been a little added pressure by me adding some time to that. I think if I gave you the complete class period and you went through it about 15 freaking times, I think you would find a number. Oh, that's here and there. Sometimes you get some pressure. But right now, I've only got 2 people that got the same. You got 74? Oh, you got both of y'all got 77? There's 2 of those? Oh, now we're at 3 of those. Wow. Ain't nobody got it right. Not a person.
I went back through the Sir County and I got 73.
You got 73. All right. We're getting better. Not really.
Is that not the answer?
No.
You said more.
So I don't tell you what the answer is because you spend the rest of the class period counting the freaking G's you missed. But here's what I want you to understand about this more than anything, okay? And I will tell you what the answer is, but let's focus back in on class, right? Right now, we tried very unsuccessfully to find the census. I bet if you randomly or you counted those rows, maybe not count the last row, maybe not count the first row, or maybe count the first row and the last row together, but I don't think you can do that. But if you counted the rows, and so I forget how many there are, let's say there's 15 rows, okay? And you can't do this because that's not random. That's not random because you're more than likely to hit one of these middle ones than one of the top of them because you're only hitting this once when you're hitting the rest of these like twice. Y'all follow what I'm saying, right? So if you take 15 numbers or a 15-sided die or a calculator that does random digits, or you get your computer out, right, and find me a random digit between 1 and 15, right? Y'all good with what I'm saying? Boom. Count the number of G's in that row and multiply it by 15. I bet you're going to get some of these numbers. Probably you would get close to the same looking dot plot. Y'all follow what I'm saying? How long is it going to take you to do that as opposed to count every freaking G? Every freaking sneaky, I'm dyslexic, right? Every freaking one of them, right? It's a whole lot faster, provided you can find a random number between 1 and 15. Whole lot faster, and it's just as freaking accurate. I don't know where freaking keeps coming from. That's my word today, I guess. It's just as accurate, okay? So that's why we do statistics. We take samples because we can judge a sample to the population just as easy as we can do a census. Here's one of your questions on the test. Which one of the following is least likely to do a census? Well, get the GPA in this classroom. Is that likely? I could get that. Probably still going to miss it somehow because one of you may have some tenths or some hundredths out there that you're not giving me, and that might mess things up just a little bit, but that, you'll kind of follow. I mean, that's possible. Finding a fish in the lake, that ain't possible. Finding the average size of a white-tailed deer, in this. That's going to be pretty dang hard. Y'all okay with what I'm, so sometimes it's not a little bit easier to do a census, but your population better be pretty darn small in order to do a census. It better be pretty darn small if you're going to do a census. This was not that big. However, it was bigger than it should have been when I could have just done a row and probably gotten the same looking data. I don't want to say, I don't like saying just as accurate, because accuracies, that's a bad thing that statisticians say, and I'll say it a lot. So try to catch me on that. It's not more accurate, it's more precise. How about that? Because accuracy, I mean, you're supposed to be able to know what a G is, but you either hit it or you don't hit it. You're more closer to it. You're not more accurate. You got the number you got. I don't know if it's more precise. They like to use the word precise more than accurate. Y'all okay with what a census is? 16. Okay, so there's my frog tail. I'll tell you at the end. Maybe. Okay, so how to sample badly. This might skip some notes, but we mentioned this word the other day, guys. Bias. Bias. Okay, a biased sample. A biased sample. This all goes with sampling, okay? We're kind of done talking about the population now. All this rest of this day is going to be talking about sampling. So this is a biased sample. When the design, okay, what I mean by design is the way that I sampled. That's the design, the way that I sampled. Okay, that's what it means by design. That's the way that I sampled. So when the design is likely to underestimate or overestimate the truth. When the design, that's kind of a big word, and the design is the way I sampled. So the way you sampled will likely overestimate or underestimate the population. That's what bias is. That's what bias is. The design that I chose is wrong. My alarm will go off at some point, and when my alarm goes off, that's when we're going to go all the way over to the south building and get your calculators for those of you that are getting calculators. If you're not getting calculators, we're done with class because it's somewhere around 8:30. Good enough with what I'm saying? So try to remind me when we get close to that. I'm going to try to get done with this lesson, but I'm really into it. We talked about that with the driving to school, the percentage of students that drive to school. I can't use you guys as my sample because it's likely to overestimate the truth. So the design, the way I selected, who I selected, that's wrong. That's a flaw. If you know it's a flaw, we got to fix that before we can even do it. If it's a flaw, we got to fix it before we can do it. We can never remove bias. You can never remove bias. You try to reduce it. You try to reduce it the best that you can. I would randomly select students from BHS. Now, it might be possible that you guys are my random sample. It's possible, not likely, but possible. Well, that would be a biased sample, but there's nothing I can do about that. Nothing I can do about that. The way you can help reduce it is to get a larger sample, right? If I get a sample of 100, it's impossible that you guys are my entire sample because I got to get 60 more, 70 more. Bias. Woohoo! Bad. It's the design. So why you want to do 2 or 3? Why don't you just do 5 or 6? Time is money. Time is money. When you're asked about bias, make sure you mention that it's likely to over or underestimate it. That's the rubric that they're going to look for. So what type of bias could have occurred? There's a bunch of different ways, right? A bunch of different ways. But then you're going to have to tell me which is likely to overestimate. My sample came from a junior-senior class, which is likely to overestimate the truth. That would give you full marks. Okay, my sample came from juniors and seniors, which does not represent the entire population. That will not get you full marks. Okay, that will get you close, but it won't get you all of them because you have to mention it's going to overestimate or underestimate the population. And you got to try to remember that from day one until May 17th or May 12th or whatever it is. All right, so let's talk about some of these bad ways to sample, right? This is a bad way to sample. Convenience. Convenience. You're sampling because it's convenient. I'm going to sample these three guys right here because I'm standing right here by them and I don't want to go anywhere else. It's convenient. Choosing individuals from the population because it's convenient. That almost always produces bias. It almost always produces bias. I don't want to say always. Here again, I told you about the squiggly words or the squishy words, right? We don't like to say those concrete words. So it's almost always. Doesn't always, but almost always. Anytime you have a convenience sample, that's bad. It's bad. Choosing individuals from the population who are easy to reach out. It's convenient to ask them. There it is. Convenient sampling will almost always result in bias. Is it wrong data? No, it's not wrong data. It's true data. It's just bad data. It's bad data. It's biased. Why? Because it differs from the truth. How? Well, I don't know what we did. I don't know what we did. Okay, everybody good? Voluntary response. Voluntary response. Who wants to? Who can? Okay, that tends to give me bad samples. That tends to give me bad samples. People chose to be in the sample. Bless you. You chose to be in the sample. Now, this is done a lot. Voluntary is done a lot. It's okay to voluntary. You just have to be careful about who your population is. You have to be careful about who your population is. So I need students to figure out how good a shape they're in. I'm going to test your heart rate, and I'm going to have you run 2 miles, come back, and I'm going to have you test your heart rate. Who's willing to do that? Well, depends on who's willing to do that is who I can judge my population of interest. If every single one of them happen to be 18-year-old female who are in good shape because they want to run, then I can only judge to 18-year-old females who are in good shape, who weigh a certain amount. Okay? It's okay to do that, but I can't judge it to everybody because it's voluntary. Okay? So just kind of recognize those type of things there. Internet polls are always voluntary. What's the used to like American Idol? You know, you call in a number. I vote for this person. That's voluntary. Okay? A lot of times, if there was somebody from Bentonville, Arkansas up there singing, I always call in. So I want that person to win. I don't know if they were the best or not. I volunteered to answer. Most of the time when you write a review on Amazon or Walmart or whatever you write a review on, most of the time that's biased because people that really don't give that strong of opinion about it aren't going to leave an opinion. It's because you really like it or you really hate it. More hates than likes. People who self-select, okay? So self-select. Under coverage, that kind of sounds what it is. Basically, you left somebody out. You left a group out that's important to the population. Again, let's go to the 3rd floor. That's my sample. Well, I'm leaving out all the other subjects. I'm leaving out all the other subjects. And again, it depends on what I'm trying to find out. Number of siblings, I'm okay. I'm okay that I left some out. I mean, it doesn't take a whole lot more to get others, but GPA, I probably need to make sure I get a wide variety of classes. But even then, I don't know. I think I left some out. I think that's probably a little biased. So you left them out some reason or another. Response bias. Now, guys, a lot of people get this confused with voluntary. Okay, so try to make sure you differentiate these two. Voluntary, you chose to answer, or you chose to participate. You choose. Response bias is you're answering untruthfully. What you need? Oh, sorry. Undercover. You left somebody out. You left somebody out. I do bad about that too. Anytime I'll try to look to see who quit writing. I try to look. A lot of this you probably don't want to write exactly what it says. You want to write it the way you want to, but okay. Undercover. Response bias. You're answering non-truthfully. The response is not truthful. Here's one of my favorite ones I like to do. This is your very first grade in this class. Your very first grade. It's worth 287 points. Where's Akshay? You're over here. Who is your favorite teacher? Oh man, you got 287 points. See how that works? May not be true. May or may not be true. Because you're responding to somebody who's probably influencing your decision. A police officer comes up to you. Do you do drugs? No, sir. Or no, ma'am. Never. Hate people that do. Right? Were you speeding? Nope. That was somebody else. Okay? Response bias. You're not answering truthfully. Voluntary, you chose to answer. You're answering truthfully, but you just chose to answer. Response means I answered, it is not truthful. For some reason or another. Okay? For some reason or another. Non-response bias, you just don't answer. Plead the fifth. Right? You plead the fifth. You don't answer. Phone calls, that's a lot, right? The spam calls, when an individual chosen refuses to participate, okay? Non-response bias. So we kind of have some different ones out there. Voluntary response, convenient sampling. Guys, one or more of these could occur. Your job is to recognize which one could have occurred, and there's 29 in here. All 29 of you guys could pick something different. It's okay to pick something different. There's no right or wrong answer. I shouldn't say that. There's probably a wrong answer, but there's no one right answer. Okay? Your job is to recognize which one occurred and then tell me why is it biased, because it's either higher or lower than what the truth is. And it's going to be pretty darn obvious. I got an example here in a second, okay, of what you could see. Y'all okay with that non-response? A lot of students think that increasing my sample size will reduce the bias. No, it's not the sample size that's the issue. It's the design, right? It's the design that's the issue. It's not the size. It's the way I did it. It's the way I did it. The way I did it's producing the bias. I got to undo the way I did it. I can't choose just you guys. I got to select more. Okay? If I select you three to figure out if you're driving to school, or you 10 that drive to school, it's not going to help bias. It's still going to be there. Okay? It's the way I chose it. I got to choose more people out of this classroom. It's the method that's flawed. It's the method that's flawed. It's not the number. It's not the number. And a lot of students, because we talk about numbers and increasing the numbers, right? If I increase my sample size, we probably get more information. You get more data. And the more data you get, the more precise you get. I almost said the accurate word again. The more precise you get, because you're getting closer and closer to the population. You're getting closer and closer to the census. And a census is right, provided we know how to count a G. In many instances, bias can occur, okay? It's almost impossible to remove it. Please, please, please don't talk about to remove bias. You're gonna get dinged on that. You can't remove it. You can't remove it. Your job is to try to somewhat even it out or make sure that I can't tell that bias occurred, okay? Our job is to reduce it. Our job is to reduce it the best that we can, or evenly spread it out. which is still somewhat reducing. What I mean by evenly spread out is if I'm, again, trying to figure out if you're driving to school or not, that's the best way I can think. Bad examples. Typically, that goes with experiments. So evenly spread it out between the groups. So you can't tell that the bias has occurred over here or it occurred with both groups. So if it occurred with both groups, then it's somewhat still equal. So your job is to reduce it or evenly spread it out. Okay, just kind of remember that. If you can evenly spread it out, you've reduced it. You can't remove it. You can't remove it. All your job is to try to do is reduce it the best you can. Okay, so we talked about this, right? When bias occurs and you're asked about it, make sure you describe how the members might respond differently. How they should overestimate or underestimate it. How did they respond differently? Okay, they responded differently because it was a police officer asking them if they're doing drugs. That's likely to underestimate the truth. It was the teacher asking them who their favorite teacher is. It's likely to underestimate the truth. It was the student who answered, yes, I drive to school, because all of their friends were asking if they drive to school. That's probably going to overestimate the truth. Explain how it would lead to an underestimate or overestimate, okay? So you're going to have a free response question on your test. It's probably going to do something like that. Again, I change them up every year. Gosh, that's just 8:15. Oh, why did I do that? Oh, because we still got a little time. It's 8:30, so. That's not me, that's you. Turn your alarm off. What am I doing? I didn't think I said it that early. Okay. Here you go, guys. Look, watch. This is a previous AP exam question. A previous AP exam question. I looked through and found one. I randomly found one. An environmental science teacher at a high school with a large population of students. So we got a high school like Bentonville with a large population of students. They want to estimate the proportion of students who regularly recycle plastic bottles. Cool. The teacher selected a random sample of students at the school to survey. So we got a random sample, so we didn't go to the science classroom and ask those cats. So we did good there, right? If I went to a science classroom, I'd probably overestimate the truth. Each selected student went into the teacher's office one at a time. Oh, this was an environmental science teacher, and the student went in there one at a time and was asked to respond yes or no to the following question. Do you regularly recycle plastic bottles? So they were asked to respond, do you recycle? I've got an issue with this already, but we're not going to think about that. Based on the responses, a 95% confidence interval, we'll do all that second semester, whatever. We got an interval, okay, a proportion of students, and they said it was somewhere between 58% and 81% or 82%. That's a pretty darn big interval. Recycle plastic bottles. How many students in the sample were surveyed? You have no idea how to do that. That's second semester. But the second part is, given the method used by the environmental science teacher, again, they're reminding you it was an environmental science teacher, to collect the responses, explain how bias might have been introduced, and describe how the bias might affect the point estimate, this number here, okay, of the proportion of all students. So what type of bias could have occurred? Response. Was there another one? Question wordy? I don't know. I think response is pretty obvious. And we're likely to what? Overestimate the truth. A follow-up question to that is, how would you reduce this bias? And the way you would reduce it is give the student a piece of paper and have them randomly select or have them circle it without you knowing what they did. Something like that. Do you recycle regularly? Yes or no, circle it, put it in the box, don't let me see it, that type of stuff. I think everything else was pretty good. It's just because the environmental science teacher was asking them. I don't think you should have anybody ask them face to face. I think that's likely to produce response bias. Y'all okay? I forgot what year that came from. Incidentally, if you see a question like, do you like Cheez-Its? And you say, everybody should because you're trying to earn bonus points. Don't. You'll get it wrong, even if you are wrong. Okay, this is how you're going to sample. First one's an SRS. SRS, simple random sample, SRS, simple random sample, SRS. You can abbreviate it SRS. We talk about simple random sample so much. You can abbreviate it SRS. You can abbreviate SRS. On the AP test, you can say SRS and everybody knows what you're talking about. SRS, simple random sample. And a simple random sample chooses a way, you don't want to write that definition. That's almost more confusing than it is. I don't know how you want to do. Every person or group has an equal chance of being selected. It says every group. I think that's a little confusing, but SRS, it's just a random sample. It's completely random. Every person has an equal chance of being selected. That's probably the best way to say it. Every person or every individual, doesn't have to be a person, every individual has an equal chance of being selected. Every individual has an equal chance of being selected. Random sample, a simple random sample. Simple random sample. We're not going to get done today. I talk too much. Simple random sample. Every individual has an equal chance of being selected. There is, according to AP, there's a bunch of ways to do this, but according to AP, or probably the easiest way to do it, I call it the hat method, or I call it the random digit table, or I call them computer. But some way or another, you got to get them, you have to be random. You have no control over it. Using your finger and going up and down is not random. Okay? If I was going to do an SRS of this group, I could do it one of three ways. This is the best way. These are the best ways. Number every student from 1 to 29. Number every student 1 to 29. Or get everybody's person's name on equal pieces of paper, put them into a hat, mix them up thoroughly. You have to say mix them up thoroughly, and randomly select one or however many you want. Don't put it back in. We don't replace it, because if you put it back in, you get to choose it again. Okay? Now, my mathematical nerds, myself included on this, would say, wait a second, it's a 1 in 29% chance of getting selected. Now it's a 1 in 28, you don't have an equal chance. You got an equal chance of everybody that's left. Yeah, it's a different probability, but it's the same probability as everybody that's left. Okay, so that's what I mean by equal chance of being selected. Another way is to number everybody from 1 through 29 and use a calculator or a computer to randomly select how many digits. But then you got to say ignoring the repeated digits, because your calculator might give you the same digit again. So if I'm trying to get 10 of you cats, I got to say until I get 10 unique numbers or 10 numbers that have not repeated anything. You got to talk about that. Unique is probably a really good word. This was question 2 on last year's exam. Question 2 talked about how you're going to randomly select. One year, I think it was, gosh, I don't remember, 20,000. And the kid came back and he goes, Coach, is it okay if I'm numbered 1 through 20,000 and put those into a really big hat? And I said, yep, it's going to give you full marks. And it did. So they don't care how you do it. Those are 2 of the best ways, either with a computer or calculator, but you got to talk about non-repeating numbers. And in the hat, you got to talk about mixing them up. In the hat, you got to talk about mixing them up. And then you also have to talk about not replacing it. There are certain things you got to hit to make sure you get the entire rubric. And sometimes you're going to leave something out, and it's okay. Just understand that it's hard to hit the exact rubric. So here's how you're going to do an SRS. You got a label. How you're going to do it, I don't care. Put them in alphabetical order and number them from 1 through 25. Whatever. Okay? However, you're going to label them. You got to label them somehow, some way, some form, some fashion. If they're already unique, you can use that. Every one of you has a unique number. You have a social security number, or you have a student ID number. So put your student ID number on a piece of paper, put those into a hat, mix them up thoroughly, pull out however many, one at a time. That is my sample. And then, so give each one a distinct number, okay? A distinct number or a unique name, whatever it is, to make sure that they're different from everybody else. Number the trees from 1 to 40. You can say it that way. It's okay. They don't care. Start off with just number the tree, number the students from 1 through 29. They don't care how you do it, as long as I number you guys from 1 through 29. That says I'm giving each one of you an individual number. Okay, there are 20,000 bugs. Number them from 1 through 20,000. Yeah, that's going to take forever, but you got to do it that way. And then you got to randomize somehow. Use your calculator, use your computer, use the hat, use the random digit table, that table 5 that I mentioned that we probably are going to use today. Okay, use that. You got to randomize it somehow. Randomize it somehow. Mix, use a calculator, use a random digit integer, whatever you got to do to randomize it. And then, so that's the hat method or electronic method, or the random digit chart. I tend to use one of the two first. The random digit chart always gets students in trouble a little bit. I have to say it because they said use a random digit table one time. Hat method, electronic, random digit table, and then select. Select your size, and they'll tell you what size you're supposed to select it. Howard, we're going to lose time bad. You guys are going to get lucky. You're not going to have homework. You might have to remove all those days. We'll have to catch up somehow. Select. If you do these 3 things in detail, in complete methods, that's going to hit the rubric. That's going to hit the rubric. The rubric will say the student mentions 3 different things, right? They've labeled them somehow, they randomized them somehow, and they got selected. And they didn't have a chance of getting repeat numbers. They didn't get a chance of, they got the size that they needed by doing it. And I'm telling you guys, that question took forever to grade last year. I know this because they were next to me. It was number 2. I graded number 1. We were about done, and they weren't even close because it took forever to grade that one. Because 289,000 different ways to do it. Because that's how many people took the test. Good? Any questions about that? Typically, we sample without replacement, right? Draw one out of the hat, you leave it out. Unique numbers. So typically, we sample without replacement. That is, once an individual is selected, that individual cannot be selected again. Many random number generators sample with replacement. Your calculator samples with replacement, except one option now, they have random no repeat. And so you can say, I'm going to use my random no repeat numbers. Or you got a computer, randomly select with no repeated numbers. You can do that, but you have to say it, right? But it's very important to explain the repeated numbers should be ignored, or until I get 30 unique numbers. We don't, if I get a repeated number, now I only got a sample of 29, and that's not big enough. They want me to get a sample of 30. One of my favorite, this is like a 325 secret, right? So I talk about this a lot in this class, a lot. And it's a fine line for what I'm going to tell you it is and probably what you might think it is. Because I'm going to tell you that means, this is the point we need to focus on. AP portion of the course. It seems easy, but it's really difficult to receive. So AP will grade, they don't give you points. They don't give you points. We give you an E, P, or I. One of three things. We give you an E as if you hit the rubric. P, you got close to the rubric. And I, you missed it. Essentially correct, partially correct, incomplete, but incorrect, whatever. Right? Your job is to get as many of these as you can. You don't have to get all these. You can get some of these. Heck, you can get some of these. Depending on how many of these you get, how many of those you can get, or how many of these you get, whatever. You don't have to get all the big ones, but you're trying to, right? So I'm going to tell you to be specific. Be specific. Throw all the names into a hat. Mix them up thoroughly, right? We're being specific. When I select students of the higher grade, I'm going to overestimate the truth because they're older kids. That's being specific. It's putting it in context. In context. So you'll hear me talk about that all the time. Most of the time the question will say in context. Each year, the State Department of Education randomly selects 3 schools from a district and conducts a detailed audit of their attendance records. Describe how to use a table of random digits to select an SRS of 3 schools from those 19. Well, I better make sure I label them somehow. I got to randomize somehow, and then I got to select them. How many do I need to select? 3. 3. There's 19 of them. Number the districts from 1 through 19. Number the districts from 1 through 19. There. I did that. So we're going, I don't care if you go here, 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 or here, here, or here, here. It doesn't matter. Don't say I'll randomly number them because you haven't randomly selected. If you randomly number, you got to say how are you going to randomly number them. Well, just number them. Just number them, however you want to. And then you're going to use they told me to use a random digit table. So this is what's careful about a random digit table. The random digit table is just that. It's just a table full of random digits. So you start somewhere. Who cares? Who cares where you start? I'm going to start at line 19. I'm going to start it on the last side of line 38. Whatever. I'm going to start, whatever. I'm going to start somewhere. But you got to choose 2 digits. You got to choose 2 digits because I got to go up to 19. Well, how does 1, 2, or 3? 0, 1, 0, 2, 0, 3. So you got to look at numbers from 0, 1 through 19 and forget all the rest. This is a random digit table. I forget which row I grabbed it from. I got to look at 2 digits because I'm going up to 19. If I was going up to 100 and something, I got to look at 3 digits. If I was going up to 1,000 something, I got to look at 4 digits. So the very first number is a 6, 9. Well, I don't have one of those. Then I got to go to 05. 1, 2, 3, 4, 5. That's the first one I'm choosing. And then I got to go to 16. I forget where that one's at. There's number 16. I think I did all this. Oh, yeah, boom. I cut all that out. Then I got to look at what? 48, too big. 17, there's my third one. I'm done. There's my 3 schools. Ignoring any repeats. You got to talk about that. You got to talk about 2 digits. If I was using my calculator, I would number the districts from 1 to 19, and I would randomly select 3 unique numbers from my calculator or from my computer. I would number the districts from 1 through 19, throw those 19 numbers into a hat, mix them up. You got to say that. Randomly select 3 numbers from that hat without replacement. Because without replacement is unique. If you don't say without replacement, it's possible to replace it and it may not be unique. Okay. Y'all written down everything you need to possibly write down from that. Sorry, I know I'm not supposed to do this. I know. Oh, 8:40 is when I got it going off. I'm good. 8:45 is our appointment, so we're good. Okay, other sampling methods. Stratified random sample. Stratified random sample. Now, guys, this is not SRS, okay? Even though it looks like it's SRS, it's stratified. So you can't say stratified as SRS. If SRS, that's a simple random sample. Stratified random sample is different. Stratified random sample. You're divided into homogeneous groups. You're divided into homogeneous groups. Some way, some form, some fashion. I guess I could stratify you guys right now by your tables, even though they're not necessarily homogeneous. Depends on what information I'm looking for. Okay, depends on what information I'm looking for. Typically, it's not that many groups. Okay, but homogeneous groups. And then you choose an SRS from each group. From each group. If I do an SRS, guys, it's possible that these three dudes right here are my random sample. It's possible that these three are my random sample. If I do a stratified random sample, it's impossible for these three to be my random sample. One of these three will be. What does that do? It guarantees you're going to cover the entire spectrum. It's typically done with gender. You want to make sure you have both genders in your sample. So if I do a random sample with you guys right here and I throw all of your names into that and I randomly select 5 of you guys, or let's say 6, it's possible that all 6 are female, or it's possible that all 6 are male, and I may not want that. So I will divide you into males and females. That's the homogeneous groups. I'll randomly select 3 of these, and then I'll randomly select 3 of these. And that way I'm guaranteed to get some of each. You're guaranteed. And that helps reduce bias. That helps reduce bias. Why don't we always stratify? Sometimes we don't want to. Sometimes you don't want to. Let's just say this is a group of 28 females and 1 male. Lucky guy. Okay? I don't know if I want to stratify because now that 1 male has equal weight for all 29 or 28 females. Right? It also takes more time and more money to stratify them because now you got to number this group and you got to number this group. You got to randomly select from here and you got to randomly select here. And heck, if you got 4 groups, you're really taking a long time. Okay? Normally it does produce more precise, but there are situations. Okay? So that's stratified. It's more representative of the sample because you're guaranteed to cover the entire spectrum. You're guaranteed to cover the entire spectrum. It's more precise. It's less varied. You're going to hear this word a lot, variability. How much it varies. Okay, it's less varied. It's more precise. It's more precise. When they're already divided, it's easy. It's not that bad, but they have to already be divided. When they're already divided, you guys are divided by grade fairly easily. 9, 10, 11, and 12. So I could randomly select from seniors, randomly select from juniors, randomly select from sophomores, randomly select from freshmen. And that way I'm guaranteed to cover the entire spectrum. And now I have a better estimate, a more precise estimate of the percentage of students that drive to school. Okay, stratified. Disproportional groups produce equal weight. Right? If there's a whole lot more freshmen than there are seniors, you're putting equal weight on them. If, okay? And then also, again, the biggest one is time and money. Time and money. It takes longer and it costs more. And so that's why we don't stratify as much. However, we will do it because it helps reduce bias. If we know that gender is going to play into it, I'm going to remove that gender and do what? Equally disperse it among the entire thing. Because if I do males and females, it's possible that all my males are seniors and all my females are seniors. But I tried to help reduce it. So then I guess I could reduce it more by doing grade, and then now you're starting to get into more time, more money. Stratified. Stratified. Everybody good? Stratified. And if there's 2 things that get students more confused about this is separating stratified from cluster. Okay? So both of them deal with groups. Both of them deal with groups. So here's stratified. Stratified. Okay? I have you into groups, your tables. Randomly select from each table. Okay? Random. That way it guaranteed one person from each table is getting selected. In cluster, you're still in tables. But listen to me, I randomly select a table and sample them all. You randomly select a table and cluster. You randomly select a table. You randomly choose a cluster or group and sample them all. Sample them all. I call it all from some. Yep. Oh, it could. Yeah. Yeah, it could, definitely could. Again, depends on what we're trying to find. Yes, but that's definitely could, right? Because typically you're in homogeneous groups already. Again, depends on what I'm trying to find. Depends on what I'm trying to find. I don't think I'd go to a baseball park and randomly select a section and ask them if they like their seats, because they probably all are the same. Y'all okay with that, right? Maybe randomly select from the section. I think stratified would be a whole lot more precise. Again, all of this can produce bias. We're trying to reduce it. We're trying to reduce it. This is still randomizing. Cluster sampling is still randomizing, right? It's just when the randomness occurs. Okay. I call this one all from some, and then the other one I call it some from all. Oh, there it is. Okay, some from all and all from some. How close did I get? Systematic. Oh, that's it. Ah! There it is. There that is. Systematic. You number them and you select every so many one. Systematic's like mathematically. You randomly pick a starting point and you go every so many one. They'll do this like at a sporting event. It's a pretty good one. Maybe you could do it when you come into school. When you come into school, I'm going to choose every 10th person that comes into school. 1, 2, 9, 10. 1, 2, 3, 4, 9, 10. That one's pretty easy. That one's a whole lot more cost effective. That one's typically faster. Okay? Systematic. Systematics. It's simple. It's convenient. You don't have to number them all. It reduces favoritism, right? You can't say it's not volunteer. It's not convenient. It's not convenient because I got it. You're my 10th one. I got to hit you. And it's not like I don't want to hit you. I'm going to hit you. You're dressed better. Try your homework the best that you can. You'll probably be okay. If you can't, for some reason or another, you get to something that's really confusing, we'll talk about it, and I'll help you out, and I'll bump that due date. But from Thursday to Tuesday, we got time. I can't believe I did finish it. Sweet. I got to hit stop on this. Where am I at? Get off of here. Oh, I got it. I know what I got to do. I'm sorry.